Alright guys, welcome to this set of notes. What these following videos are going to do is they're going to follow along with the notes that come out of your book from Chapter 3, Section 5. Chapter 3, Section 5. And what we're going to be doing now here in Section 5, as you can see from the title, is we're going to be looking at some basic matrix concepts. And you're probably thinking, wait a second, what? I know. So, matrices. First of all, you probably have had very little sort of interaction with matrices in many of your classes. If you've seen them, you may have seen them before in biology, possibly physics if you've taken that. Also has some application in chemistry and those sciences. But probably for most of you, this is the first time you're going to be seeing matrices. So that's going to be like, this is coming out of left field. Plus the fact that we were just in the previous sections doing systems of equations. Like, what's the connection? How can we go from doing systems of equations to now doing matrices? Well, I'll get to that in a second. But before we talk about that, let me go ahead and highlight the learning targets or the objectives for you, what you should be able to do by the time we get to the end of this set of notes. And I've got them right here. The student will be able to add and subtract matrices. So we're going to do some operations, arithmetic with matrices, in this case addition and subtraction. And the student will be able to demonstrate multiplication by a matrix scalar. So those are the things that you should be able to do by the time we get to the end of this set of videos. Now, what does this have to do with systems of equations? Well, I explained that to you right here. What we're going to do in this class here in Algebra 2 is first give you a quick introduction to matrices. You'll become pretty familiar with them and a lot of the sort of operations you can perform on matrices. Addition, subtraction, scalar multiplication, multiplying matrices. We'll find inverse matrices, determinants, just to name a few things that we'll do with matrices. But once we do all that stuff, we're going to learn a couple of different ways that we can use matrices. Oh, highlighter. Couple of different ways that we can use matrices to solve systems of equations, which is what we were just doing, right? Solving systems of 2 or 3 equations. We did solving systems of inequalities. So we just got done doing solving systems, graphically, algebraically, all that good stuff. And now we're going to go ahead and in this class here in Algebra 2, we're going to use matrices to solve systems of equations. We're actually going to learn a couple of techniques. In Section 7 of this chapter, we're going to use what's known as Kramer's rule to solve systems of equations. And then in Section 8, we will use matrix equations to solve systems of equations. So for those of you who are already familiar with common operations with matrices, please feel free to just skip ahead to Section 7 and Section 8 to take a look at Kramer's rule and systems of equations. But for those of you that aren't real familiar with matrices, stick with me here. We'll give you everything you need to know before we get to those processes of solving systems of equations using matrices. Now, what is a matrix? For most of you probably wondering what it is. Well, I've got for you here a matrix is a rectangular array containing either constants or variables. They're going to be enclosed by a bracket, and generally matrices are named using a capital letter. Also, I just want to point out each value in the matrix is called an element. So whether it be a variable or a number, we're going to call each individual object in the matrix, it'll be known as an element. It'll have a certain position in the matrix, and we'll name the matrix with a capital letter. So let me show you a couple of examples of some matrices I've got for you here on the very next page. All right, so these would be examples of a couple of matrices, matrix A, B, and C. Please notice that what they've got, in this case, I just use constants, just numbers. We certainly could put variables in there instead, and we will. The variables are coming. And those matrices are enclosed by brackets. So just a couple of examples. The matrix can be as big or as small as you'd like it to be. It depends on how many elements you have in your particular matrix. I will make one quick note here before we move on to what we're going to do here in this section, and it's this. It is possible to write an equation with matrices. For example, if I have matrix A and I add matrix B, that could be equal to a matrix C. So by writing these equations, what that means then is we would be able to solve a matrix equation, and essentially that's kind of like a preview of what's coming. In section 8 of this chapter, we're going to use matrix equations to solve a system of equations, and this is what allows us to do that, the fact that we can write a matrix equation and solve that matrix equation. But that's all coming later in section 8. Just want to make mention that that is possible. Here's kind of the big deal right now. As we're learning the matrices and just sort of becoming introduced to them, dimensions. The dimensions of the matrix, being able to determine a matrix dimensions, and being able to set up a matrix with the proper dimensions is going to be a very, very important skill for you to kind of master. So let's talk about dimensions. Dimensions of a matrix will refer to the number of rows that the matrix has and the number of columns that the matrix has. Let me show you. The three matrices that I had given you guys up here. Well, let's just go ahead and take a look at this. What we mean by a row is we mean moving horizontally across the matrix. How many rows of elements do you have? Well, in the first one, I've got this row, and this row. So it looks like I have 3 rows. Now, when figuring out the dimensions of a matrix, rows always comes first. So this matrix would be 3. And then we figure out the number of columns. Again, columns are going to be moving vertically through the matrix, elements that are lined up vertically in the matrix. So I have 1, 2, 3. I have 3 columns. Columns will always come second. It's always going to be rows first, then columns. Oh, sorry, hang on. I forgot my N. Rows first, then columns. Also, one other quick little note here to mention. Since the number of rows and the number of columns happens to be the same, 3 rows, 3 columns, we actually call this a square matrix. We'll talk about that a lot more here in just a second, but let's try another one. So again, I want to figure out what are the dimensions of this guy. We always do rows first, then columns. So I take a look at it, and it looks like I have 1 row of numbers. So this matrix would be 1 by, now I need the number of columns. Well, I have that set of elements. It just has 1 element in it, but it represents a column, and then the 0 represents a second column, so that would be a 1 by 2 matrix. Keep going. I got the next one here. 1, 2, 3 rows. Rows go first, then columns. 1, 2 columns. So what we see here is this idea of finding the dimensions of a matrix based on the number of rows and the number of columns. Now, for abbreviating dimensions, M is always going to be rows, N is always going to be the columns. M first, then N. M is rows, N is columns. Rows, then columns. Very, very important. Please make sure that you remember that. So here's what we're asking you to do. How many rows and how many columns does a 4 by 2 matrix have? Actually, I'm going to add to that question. I want you to do one more thing for me. How many elements are in this matrix? All right, we got a lot of work to do. Here we go. Now, if the matrix has dimensions of 4 by 2, well, we just talked about the fact that rows come first, then columns. So if the matrix is 4 by 2, that means I must have 4 rows, 1, 2, 3, 4, and I must have 2 columns, 1, 2. All right, now I'm going to put my matrix in brackets, right, because matrices always go in brackets. And I ask you to figure out then how many elements are in this matrix. Well, an element would go everywhere my lines intersect. So I would have an element here, could be a number or a variable. I would have an element here, 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 there, 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 and there, right? So if I had elements, constants or variables, whatever, they would go in those positions. That would give me 4 rows, 2 columns. This is a 4 by 2 matrix. And how many elements does it contain? Yeah, it contains 8 elements. Numbers or variables could be either or. All right, hopefully that gives you a good idea of what we mean when we talk about the dimensions of a matrix. Please remember it is rows first, then columns. M for rows, N for columns. So a matrix will always be M by N, whatever M and N are. Head on over to the next page of the notes and we'll keep talking about matrices. I'll meet you there.